I'm in my task definition. I have changed my latest task definition only to use fewer number of compute resources. So if you explore that, you can find that right now it's used only 256 CPU units and 256 megabyte of memory. The reason being we are going to run multiple such tasks on this cluster. So the challenge with running a task is for some reason, if you start a task and the EC2 instance that runs that task crashes due to some kind of a disaster or some failure, that task won't automatically start. But in the case of service, the ECS knows how to maintain a desired set of tasks running. So let's create a service. So there are two types of launch types that you can create. One is Fargate, one is EC2. As we are using an unmanaged cluster, we are going to use EC2 in this case. For the task definition, you can select my batch app task. Depending on how many times you have changed, you may have multiple versions. In my case, I have changed it 16 times, so I'm selecting 16 here, the latest version. In your case, it may be a different version. Give it a service name, something like my batch app service. Service types select as replica. So this is different from daemon. If you want to get a help, you can click that icon next to the name. So how many tasks I want to run? I want to run 4 tasks. So the service will maintain that 4 tasks. Minimum health and maximum health % defines how we are going to do a role-in deployment. And for the deployment type, I'm going to select a role-in deployment. That defines how I'm going to update this task when a new version of this task comes into place. If you want more information, you can select that icon, which will give you a description of what that option actually means. So there can be multiple placement types. You can select a balance spread, 1 task per host. But in my cluster, I only have 1 container host. So I'm going to select something like bin packing. This is a batch application I'm running. So there's no need of doing load balancing like a website. So just keep none for the moment. Go to the next step. I'm not going to auto scale. It will be another lesson. So we just select the next step. So we select everything that we need to configure a service and then create the service. So what will happen is you can find in the service definition that the desired count is 4, but the pending count is 4. There's no, and the running count is 0. Service understood that the running count is not equal to the desired count. So it automatically started 4 tasks. So if you give it enough time, it will start 4 tasks. You can find that it started 4 tasks. If your EC2 instance doesn't have any content images, then it has to go there and then download. So it may take a bit longer than my EC2 instance in this case. So right now it's in healthy state, the desired count equal to the running count. To simulate some kind of failure, let's say EC2 instance crash or some kind of a virus attack, maybe you manually go there and then stop these containers. So let me simulate some failures of this task. So what I'm going to do now is to go to a few task definition, the running task, and then going to stop them. So this is, I'm just doing a simulation of a failure of a task. And the second one is, so I'm going to stop. From the time that I stop it, you can find that there's only 2 running tasks. And the ECS understood that there's a deviation from the desired state. And if you keep refreshing, what will happen is ECS will automatically start 2 additional tasks so that the running count will equal to the desired count, and the desired state of the cluster will equal to the running state. So right now the running state is in good condition. The running count equals to the desired state. So that's the beauty of ECS. So you can maintain, let's say, some desired number of containers to load balance your website. If you go into this task definition, let's say you stop this EC2 instance, what will happen is, okay, the cluster, the EC2 instance that provides the resources to the cluster is going to terminate, and all these tasks will fail. And when the cluster recovers, maybe it starts a new EC2 instance as part of auto scaling, it will automatically place these tasks in the new EC2 instance. You can go to the events and then observe different events happen in this service. So for example, when we first created the task definition, it started 4 tasks. Then we know that something bad happened, and what happened was ECS realized there's a deviation from desired state and then started 2 additional tasks. So you can find it over here. So by looking at these events, you can trace back and then see is there any deviation. If there's a service disruption, we can trace it very easily. Deployment is where you identify if there's any new deployments happening in this service. For example, as of now, I have this primary deployment with the desired count of 4 and the running count of 4. When you do some automatic deployment, you will find some additional deployments appearing there. Of course, I don't want to run this service forever. To clean up this lab environment, there are multiple ways that you can stop the service. So right now I have this service running. If you keep running it, it's going to use your T2 instance credit balances. So one way to stop this service is to go there and then delete it. The other way is to update it, and instead of running 4 tasks, you can run 0 task. So I set the number of tasks to 0 and then click next, 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 and update the service so that service will realize that, hey, you are running more than what is required, and it will stop some of the running tasks. So right now, the number of tasks is running is 0. So that's one way to stop a service. You set the the desired number of tasks to 0. You can, of course, completely remove a service by selecting it and then deleting it. In this way, I'm making sure that I will not run out of T2 instance credit balances in my cluster, because this service after deleting is not going to use any of the resources. In production environment, what you usually do is you update the service so that the number of tasks that the service starts is 0. So that in that way, if you have some dependency like in a continuous delivery system, you don't crash that system.